represent today one of the greatest therapeutic and diagnostic modalities in modern medicine, with application in the treatment of major diseases like inflammatory and autoimmune disorders, cardiovascular diseases, and cancer. More than 70 monoclonal antibodies are nowadays available on the market, with a sale which is expected to grow up to $125 billion in the next future. Traditionally, monoclonal antibodies are manufactured from batch cultures using mammalian cells, followed by extensive purification steps that rely primarily on discontinuous and cumbersome chromatographic techniques, with intermediate filtration and viral clearance. Unfortunately, several chromatographic steps are required to reduce impurities like whole cell proteins and DNA, with an increase in production costs. Crystallization is an effective, cheap, and scalable technique conventionally used to purify small drug molecules. Up to now, the purification of biomolecules directly from clarified fermentation broths has been prevented by the structural complexity and flexibility of the target molecules and the presence of impurity in cell culture media that hinder nucleation and growth steps of the crystallization process. The primary goal of the Amecrys project is to unlock the industrial application of protein crystallization in biopharmaceutics by combining the continuous manufacturing concept with the efficient crystallization process based on membrane technology and selective recognition of complex biomolecules in multi-component solution by engineering three-dimensional nanotemplates. Template-assisted membrane concept also in this project is expected to allow a selective recognition of protein molecules in fermentation broth, whilst membrane will facilitate the filtration step and afford crystallization efficiency. By this strategy, crystallization has the concrete potential to completely replace chromatography in the production of antibodies, with significant benefits also in their final formulation due to high biostability of the crystalline state. Amecrys researchers aim to replace chromatography with a single membrane crystallization unit, developing a continuous prototype for industrial purposes, so that financial and operating costs in antibodies downstream processing will be reduced by more than 60%, thus making production costs more affordable, enhancing product shelf life, while achieving the same drug properties in terms of therapeutic activity. The Amecrys consortium involves research institutions, universities, and industrial partners from 4 European countries, the Italian National Research Council that coordinates the project, the University of Calabria, the French Centre National de la Recherche Scientifique, l'Université Libre de Bruxelles, the Imperial College for Science and Medicine, the University of Strathclyde, GVS, Center for Process Innovation, Fujifilm Diosynth Biotechnologies.